All right, everyone, I'm Yelena. So tonight is our introduction to R and RStudio session. So here is the agenda, and again, it's going to be a lot to cover tonight, so trust me, you may need to watch the recording of this session more than once, or certain portions of it, all right? So here is the agenda. We're going to talk about what is R and what is RStudio. We're going to talk about the RStudio environment and its interface. I'm going to show you how to save all your work in an R file. We're going to talk about using variables. We're going to talk about reading data, right? And we're going to talk about data exploration, data visualization, and some useful resources. All right, so let's get started. And here, just a screenshot of the data that I'm going to use for this demonstration. We will use the human resource data that stores the employee past job satisfaction level, the number of years after last performance evaluation, number of projects that the person worked on, etc. Monthly hours salary. But the whole idea is to tell if the employee left the company or employee still stays in the company, right? So that's the data that we're going to look at later tonight. It's just a preview, and I put the source here. All right, so what are we talking about? What is R? And what are its advantages and disadvantages? R is a language for statistical analysis and for data visualization. It's an open source, and it's available to you at no cost. You download it for free. It's available regardless of your operating system. Excellent data visualizations and advanced statistical methods. The commands could be saved in a script, and you can rerun them to reproduce the results. You can share your script with your professor, your teammates, if it's a group assignment, etc. Right? So, and there is a powerful online documentation. The language, it keeps growing. New packages gets developed as we speak. It works well for us, for academic environment. It can also be used in databases. Then there is more than one way to produce the same result, the same output. And R also supports parallel processing. However, like other languages, there are some drawbacks. There is no graphical user interface. You need to put some effort into practice and learn, and you need to get comfortable with reading help pages. Remember that R language is case sensitive. It might not solve all your data analytics problems that you're trying to solve. You have to keep updating the packages regularly. Then, in order to install R, you must have admin rights on your PC. Or at least, if you're asked to enter admin username and password, you need to know what that username and password is. All right? Then, remember, R, you cannot embed it into web applications because it lacks basic security and it runs slower than Python or Java. So those are just some drawbacks, right? Okay, so how do you start? You need to install the latest version of R, right? So there's a separate web page for Windows and for Mac. You download the R first. Then you're going to download the desktop version of RStudio. Download R first. Well, because in general, you can run R without RStudio, but you cannot run RStudio without R. You're going to get an error. So download R first, right? Then go back and download RStudio. It does not take long to download, but again, you have to have your admin, you have to have admin rights on the PC where you're installing it, right? So I just mentioned RStudio. What is RStudio? It runs on top of R. It's an integrated developer environment, and it makes things a little bit easier. You may run the code directly. It supports the syntax highlighting, all right? And you can see the commands history. So when you install it, this is what you're going to see. This is what you're going to see when you install it and launch R. So here, it shows you the version that it's currently using, right? And the latest R version at the moment is 4.4. I did an update before this presentation. I got the latest. So this is the latest one, right? And it's gonna tell you when this was version released, etc. Right? So this window that I'm looking at right now, this is called the console window. What you see here is the messages. Some messages are error messages, some messages are informative. You're gonna see the commands that you run. You can type the commands directly, or when you run the commands in a source file, which I'm gonna show you shortly, the commands will be echoed in this window, and you're gonna see the output here. Like for example, the very first command is version, right? Just an example. See, I can run the command like this, and I can see my output here, right? So that's about the console. Then what else do I have? Important window here is an environment. Environment window is going to show you all objects that you have right now in memory. At the moment, we don't have anything in memory because I did not create anything, any object. I did not load any data. I did not do anything. I started the clean session here, right? Then you've got a history. What's a history? It's a history of commands, right? The latest command that I ran. See, that was the last command version. And if I wanted to rerun the last command, I could highlight it. Then I could click on here to console, right? That would put the command back here, and I can click enter. I can rerun the command that I ran like this, or I can also use up and down arrow, right? I can use up and down arrow on my keyboard to go through the history, right? So we don't worry about the connection in this class. For tutorial, it's something you can do at your leisure. There is a package that you could install and explore, but not required. So now what else do we see? Files are the files that are located in your working directory, and we'll talk about the working directory. It's a folder where R by default is looking at, right? So if I try to load data, perhaps that's a location where it's going to look at by default for that data. Plots, you're going to see the plots that you built, right? Data visualizations are going to be here. Packages. Everything in R functionalities are organized into packages. Package is nothing but a set of functions. You could have some data sets on it. You can have some vignettes on it and a documentation. So it grouped together, right? Like, for example, in your first assignment, first exercise, you'll be using iris data. That data is part of this package, data sets. See, everything is R is organized in packages. There are different types of packages. System library are the packages that come pre-installed with R. And user library, and I'll show you when we get to it, it's packages that you installed by yourself, all right? And help is very powerful help on commands. Like, see, like for example, if I look up the bar plot command, here it's going to give me the command description. It's going to give me the parameters that the command takes, right? Different options for the command, right? Arguments. It's called arguments. It's going to explain what those are. Then, if you scroll down, there are actually some examples that you can run to practice, right? And those examples are on data that was pre-installed with R. All right? That's that. All right, so let's go back to the slides for a minute. I showed you what those windows are. Okay, now R script. You want to make sure that all your work is reproducible, or if you created something, right? And suppose that you loaded data into the data frame. We'll talk about the data frames. And by mistake, you deleted the column. What are you going to do? There is no undo button, right? But there is a nice solution. And what is the solution? You need to save all your work in the source file. So see how you're going to do this file. You're going to click on new file. and you're going to select R script, right? The extension of the file going to be .r. You're going to type your commands in here, and you're going to just save it, see? Save it, right? Give it a name and save it on your drive. But for you, for today, what I did was I prepared the script that I'm going to use in this demo. So to open the saved R file, you just go open file and search where you saved file. But I'm going to show you a little shortcut here. Here, you can see the files that you had recently opened, see? I recently had this introduction to R open. I can just reopen it, see? So that's one way to open a file. So remember, you need to save your work. Why? Because that way, if you have to stop in the middle of the assignment, when you come back next time, you can get back to where you stopped at just by rerunning the code. If you accidentally delete the column, right, no problem. You can just rerun the code, reload the data, right, and rerun the code if you have all that code. But if you did not save it in a file, it will be hard to reproduce the work that you did. And I believe you also need to submit the code as part of the assignment deliverable. All right? So here is the R script, and the file has extension .r. All right? So, and I'll show you how to run the script. Earlier today, right, I showed you how to run a single command just by typing the command in the console window. But if you want to run the script, well, one way is to place your cursor on the line that you want to run and click run. I just do it like that, see? And you run the command above. In R, as I mentioned, there is more than one way to produce the same result. So if you want to check the installed R version, you can type r.version or version. Remember, case sensitive, right? So this is how you do it. You can run the command at a time, right? We're going to do it this way tonight because I want to explain what those commands do, right? Or you can do also Control Enter, right? It's another way. Or you can highlight multiple lines to run. Another thing that you may notice that, see this in green, what is this? Those are the comments. The comments describe what the code does. And it will help you because what I'm going to give you after this, you're going to have a copy of this code. And you will be able to see what was discussed during this presentation, right? So, and if you have to go back to it in a few weeks, you will know what it's done, what's done here, right? So that's that. You remember to add descriptive comments, right? So here, we talked about the console window, right? We talked about how you may minimize and maximize. You may resize the windows if you like. See, those panels are adjustable here. So that's customizable. That's that. So, So now we're gonna start, and I prefer to do it just by running the commands and show you. So another one was a session info, just gonna tell you the current settings. So see here, attach-based packages. Remember I mentioned package is a set of functions, right? So attached, it means that it gets loaded. It's not only pre-installed, but it was loaded in memory at the time when I launched RStudio, all right? And those are the settings on my PC, etc. Right? And the next thing is this will show you the time, system time. ls command is going to show you the objects that are currently in an environment. At the moment, I don't have anything. And another way to see that is also by running objects command. Remember, there is more than one way to see the same result, right? You might be wondering, what is this little subscript one? Well, everything in R is a vector, right? Including the output. So here, this is a vector, and the position of the element on this line, right? Of the position of the first element on this line is 1. It will make more sense when the output spans multiple lines. But this is just, it's a vector, see this? That's why. And the elements are numbered from 1 in R. Right? data is going to show you what data is pre-installed and in memory. And if you scroll down, you're going to see that the iris data you're going to use in the exercise was pre-installed, and the iris data is part on the dataset package, right? It's in here. So now I'll just close this. Next thing is you can use R as a calculator if you wish. For example, I'm just doing 5 plus 9. See this? Again, you'll see this number 1 because it's a vector. I don't see anything still in the environment because, well, I did the calculation, but I didn't assign the result to anything, right? I didn't assign the result. I didn't store the result. Then here you can also print something like welcome to data mining. It's just going to output the text. Now it's different because I'm going to assign number 3 to X. All right, so assignment, this is assignment operator. I'm going to run this command now, and notice X got added to environment. And if I was going to go back, and if I was going to run ls command right now, it would return X, all right? Next thing, how do I output the value of X without looking at the environment window? I can just do type X, that's it. I can type print X or I can type X. There is also a shortcut. If I want to create Y, assign 5 to a Y, and also output in the same command, what you do is inside the parentheses, right, you assign 5 to a Y, and then output, see? Like this. So this will create Y, assign 5, and output. I know some of you might be thinking, oh, that's a piece of cake. Yes, I understand, but those things build up, right, into complex things. So now I've been working with stuff, and as I get working, my global environment gets filled up, right? So that's a global environment. See, and you can see over here environment, you can look at the grid view, or you can look at the list view. But when you're looking at the grid view, sometimes see here, you'll see the size. In this case, it's small, but maybe you have something that you no longer need, right? So how do we remove it? Well, of course, you can click on X here, for example, and click on a broom to remove X. You can do that. But the point is, how do we do this programmatically, right? So to do it programmatically, you're going to run rm command and you're going to specify X. Now, if you want to remove, if you have 100 of those and you want to remove all at once, this is what you do. Rm command can take the output from ls command as an input. Ls lists all objects in a memory, right? So here, you pass in the output from ls into rm. This will remove everything in the memory, right? So just know that. Now, here, options are just going to tell me what my options are. Like, for example, the timeouts. Then also, if the output is too long, after a certain number of characters, it's going to cut off. So it's a matter of how many characters to show, etc. So you can look through that, right? So this is a warning length. So it means if your warning message is too long, how many characters to show, and more. Okay. Now, this one is how to clear the console window. Just run this command, it will clear. Dev off, it's not going to work at the moment because I don't have any plots. I have not done any plots yet. And history 5 is going to show the last 5 commands. It's here. See, that's a history. All right. So did I tell you that everything in R, the things in R, a lot of things in R are vectors, right? How do we manually create a vector? We use command. The command is called combine, right? And you write it as a C. It's a combine command. And you can combine the values into a vector. So how do we do it? You just put C, right? And then as an input, I put it 1, 2, 3, 4, 5, just to spell each element out. Alternatively, I could just put like this 1 through 5, right? But first, let's see what this does. This only outputs the elements 1 through 5. if I go back to my environment, I didn't assign it to anything. So now what I'll do, I'm going to assign it to X, and also here, see, I'm gonna assign it to X, but instead of listing all of them, I'm just gonna say 1 through 5. Okay, good. So see, now I've got my X in here because I assigned. All right, so when I just type X, I output X, but note that this is an uppercase X. If I was going to put lowercase X, I see this, I would get an L. X not found. It's because R is case sensitive. All right. Okay, now let's assume X has 1000 elements, and I want to see only the third one. So what you do is you put a subscript here and you specify the element that you want to, you specify 3, which means third element. So this command here is going to display just the third element of X, right? But again, this is just because the output is a single line, and output is a vector, and the first element is at position 1. Here, it's just going to show the data type of X, and these are multiple ways. I like to throw multiple ways in here because what you see will depend on the book that you use, right? Now, suppose that I want to create another one. I want to use combine command to create Y, where Y is a list of numbers 1 through 5, and then 8 through 10. I want to skip 6 and 7. I still don't have to spell all of the elements out. I can do this 1 through 5, comma, 8 through 10. So I'll just do that. See, I created a Y. I can output Y. Also, if I want to see elements 3 to 6, I just put like this, right? In the brackets that I want to see 3 to 6. X of 3 to 6. Oops. It's because I highlighted part of the command. So I just put the cursor on the line and run, and then does it. Data type of Y, see, always check your work, right? Data type, and this is the structure of Y. Now, if I want to multiply each element of Y by 2, I just can say Y times 2. This will multiply every element of Y by 2. And then I check, here we go, right? Now, we look at sequences. What is a sequence? Well, in this case, we're going to create 10 elements, and it's going to start from 1, and it's going to be incremented by 1 because I don't specify, right? And I'm going to assign it to Z. So I'm just going to run this. So what is this? This is a sequence of elements 1 through 10. I didn't specify how to increment, right? So then it's going to be, it's going to increment by 1. I did not specify the start also. So it's going to start from 1. I only say that I want to do 10 elements. Default is 1. Now I'm going to specify the start and number of elements, right? So that is going to start from 2, see? Because I specify the start and end number rather, see? See this? I want to go from 2 to 10 in this case. And now here is going to be 2 to 10, but I want to go in steps by 2, right? I want to go by 2. So here, in this case, I only said I want to end, but I did not tell where I want to start. So it's going to start from 1. R has very powerful help system. It's going to be your best friend. So how do you use a help system? Multiple ways. You can go to this help window and search for your topic. Or you can do that programmatically. How? Well, one way is to put the word help, right? And in parentheses, type the command that you're looking for. Or you can just put a question mark and the command names that you need help for, and it opens the detailed help page, right? Including the package where the command is in. See, this bar plot is in graphics package that was pre-installed with R, and you see here different input options that it can take, right? And some examples that you can actually practice. It's using some data sets that are pre-installed, right? So, and then suppose that I'm not sure how to spell my command name, no problem. There is a command called apropos, And in this case, it's gonna list all functions that contain bar in their name. So then once I get the name of my function right, I can just type question mark and put the name of my function to get help page. I could also display examples, right? You're gonna run through examples. You can type example and specify the command name, or you can also search online, have manuals for the bar plot, right? This will open your default browser and online. See, it's opening the default browser and some of the manuals on the bar plot because I searched for the bar plot, right? All right, so for your first exercise, you're using data that was pre-installed. But what happens if you're asked, which you will be, second exercise, the data is not pre-installed. So what you need to do is you need to read data from your hard drive into R. How do you do it? Well, first of all, on my C drive, I created folder and I called that folder dataset. So I have this folder. And in that folder, I uploaded the files that we're gonna upload to R right now. And I'm gonna give you a copy of that file. But in order to, if you want to follow along the code, you would need to create the folder called dataset, right? Either create this folder like this, or if you create a folder with different name, you will need to edit the code, all right? So now, if I just go in and try to read data, I won't be able to right now at the moment because I need to set the working directory. I need to set the folder where I want R to read the data from, all right? See here, shows files in the working directory. There is nothing in here like this file, see? Like if I run to check if this file exists, it's gonna tell me false, see? Because I need to set the folder to the folder where I saved it. So set WD command, set the working directory. And notice that in here in the title bar shows the working directory. It gets updated. Another way to get the working directory, you run get WD command, and it's gonna tell you what the working directory is. This command here is gonna list the files in the working directory, right? Here, just to show a file exists, we did that. And here it comes. Right now, we are going to read our file into R. The file is CSV. The first line in the file contains the column names. We want to make sure that we read the column names correctly, right? So here I specify the file name, and it's case sensitive. I specify that I want to read the headings. It's comma delimited, right? And here I want to make sure, well, I have some columns where the values are string values, and you'll see it, but I want them to be read as categorical values. So I just put as is false because otherwise it reads data incorrectly. So let's go ahead and read this. Okay. Now, what does this do? View is going to open the spreadsheet view of your data. This is a spreadsheet preview of your data, right? But this command head is going to display the first 6 rows in the console. I did not specify how many rows I want to see. Default is 6. Notice that the all columns do not fit on a line, so it's going to wrap. All right, it's going to wrap. I could adjust the panel width, etc. But if it does not fit, it's going to wrap around. Here, head, I can specify how many rows I want to see, right? Similarly, tail is going to show the last 6 rows, or I can specify how many, all right? So now here it comes. I just read HR data. Let's work with it. So let's look at the properties first. The R object is called data frame, but if you look at it here, global environment, it's over here. See, you can see it. And what is this? See, it says the number of observations on number of rows, and this is a number of columns. And it lists here each column and its data type, right? So notice this here. Some columns have these categorical values, like salary. The values are high, low, medium. We want to make sure that this column is read correctly, right? So that's the reason I had to say as is false. Otherwise, it would read it as a text. I want this to be read as a factor, see? Level is a number of distinct values. That's what it is, right? So now, but suppose that I don't have this nice window. How do I see the structure programmatically? I need to run the str command and specify the data frame name. So I run this and I see this output in here, see? There we go. Now, class command is going to show me the data type, which is data frame, or I can also check if it's a data frame. There are several ways to display column names, but see, sometimes it's important to know how to get column names programmatically because you could use it as an input to another code. For example, I want to do something for every column, so I have to loop through the list of column names, right? So how do I list the column names? I can run names command, right? Or I can run column names command. There are two ways. Now, suppose that I need to know the dimensions of the data of my data, and I don't have this nice environment window. You're gonna run dim command. See this? And what dim command does, it outputs a vector of two elements. The first element shows the number of observations, and the second element shows the number of columns. So, but if I want to see only number of observations, I can run nrow command, or I can run the dim command above and only display the first element. See, it returns a vector. I can see as the first element of the vector, right? And here, number of columns. Well, multiple ways. I can say ncol command. I can say length command. Then I can reuse my dim command above and take the 10th element, second element, sorry. And here I can also do, see this names is a list of column names, the length of the list of column names. See, there is more than one way to produce the same output. Next thing is descriptive statistics. For the entire data, if I want to see the descriptive statistics for the entire data, I run the summary command, and in parentheses, I specify the data frame. So see here, I'm going to do summary HR, and what it does, it's going to output. What does it output? Let's look at this. If you have numeric columns, it's going to give you the 6-number summary, right? What is it? It's a minimum, first quartile, medium, mean, third quartile, and maximum. It's going to do that for numbers. But look at this. Last evaluation, it says NH. What is that? Well, you have one row. You have one row where the value for last evaluation is missing, and we'll get to that. We'll get to missing values. But in here, you can see if there are missing values. See, it shows. All right, so that's for the numeric, but you also have the categorical columns. See, for salary, it looks clear. High, low, medium. You have only 3 values, and it shows you how many rows have each value. But what's going on with the department? Well, you have, 10 departments, right? But what it does here, it shows you only 6 dominant, and it groups everything else as other. By default, it's showing you only 6 dominant departments, right? 6 departments with the most people, right? Each row is a person, if you will. So see here, it shows you the most dominant, and everything else is grouped as other. But what if I want to show all of them? Here's how you fix it. You need to specify this parameter, max sum equals 9. Right, so that will show more. That will show more. In this case, see this, I see 9 of them. See, in here, it was only 6. now I went down to 9, see? All right. So, and here, this one is just going to show, see this, like if I want to see the summary just for one column, what you do is you specify data frame name, $, followed by the column name. Remember, case sensitive, right? So here we go. Here, I show only for one column. There is another way to show the summary, but it's almost the same information, but not quite. I can run lapply command. Lapply command runs the specify command on each column at a time. So I run lapply. Here is the data frame name, and this is a command name. I want to run the summary on one column at a time, and let's see what's going to happen. So here it's going to list, right? Almost the same 6-number summary, number of missing values. But what's different here is that for categorical columns, I see all values, not just the dominant one. And I see the number of rows for each value. Same goes here. See salary, right? What if I want to see only minimum? I just type the minimum command, right? If I want to see minimum or maximum, I use range. There is also standard deviation that's not part of the summary, but you can type SD command to see it. Unique is going to list unique values of the categorical column. Same does the levels. See, there's multiple ways. But here I want to see the highest satisfaction level per department. So I can use aggregate command, right? I'm using the maximum function, and I'm aggregating by department, see? So I could do that if I want to. Now, suppose that my data is large, and I want to look at only the subset. So what you do is you specify the data frame name, and in the brackets you specify the range, the positions of rows, right? You like here you want rows 1 through 5, for example, right? Comma, and then you specify the columns that you want, right? Like for example, this example might be a little bit simpler, where I take 5 rows and I take 3 columns, the first 3 columns. See? There we go. Right? I specify here by position, but in here, the columns list is omitted. So that means it's going to show me the first 5 rows and all columns. Right? But this is just the output. Alternatively, I can create another data frame, and I can assign the first 5 rows to another data frame, right? So I can assign. So that added another data frame in here, see? So that's an assignment. All right, so this will just show the first 3 columns and 5 rows. Or, see this? But you could also do this. You don't have to specify, well, that's another way. Here I want to see the 6 columns, but what is this? Names returns the list of column names, right? It's just another way to do this. Then, what if I don't want to see columns 2 and 3? I want to see 1, 4, and 5. Then I can specify here 1, 4, 5, right? C is a combine command. See, we're reusing the command we talked about earlier, right? So I create this little vector in here. I want the first 5 rows, and I want to see the columns at position 1, 4, 5. Or instead of specifying the column position, I can specify what the column name, right? But here I omitted the rows that I want to see. It's going to try to return all rows, but it's going to be, oh, what is this? Remember, I mentioned that there are options, right? So if the output goes longer than certain number of characters, it's just going to cut off. It's going to omit. It's not going to display, all right? So it's always good to look at the subset. Now, so I have the salary column in HR data frame. What if I want to see the first 4 values? I want to see only that column and the first 4 values. How do I do that? I put the data frame name followed by the $sign. Here's the column name, and I specify I want to do 1 through 4, right? First 4. Here, I can specify the criteria. For example, I want to see the rows. Which rows do I want to see? Only if the salary is medium. I specify the condition for which I specify here the condition for the rows to be returned. I don't specify which columns. It means that it will do all columns, and it will return only the rows if salary is medium, right? Still a lot of rows. But as I'm looking through this output, as if I see somewhere that the salary is high, it means that my command is not working. I need to go back and fix it, right? Then here it just shows that you can combine conditions. I want to see salary is medium and the department is HR. So this is how you combine, okay? Cool. Next thing is, how do you add a column? Well, all right. I have we have time spent with the company. There is a column called time spent with the company, and it's a number of years. Let's just imagine you want to add how many months somebody spent with the company, right? Let's pretend to just round it, right? Approximately how many months? So you would just multiply. You want to add months spent column, and you want it to be set to the time spent multiplied by 12. What you do is you put the data frame name, $sign. This is the name of your new column. Assignment operator. Then what do you assign it to? You take in the time spent in the company column and multiplying the values by 12. All right, so let's do it. I'm going to do that. And then I'm going to run the head command. Why? Because I want to preview that, in fact, I have this. See, I just added this column. And here, number of years, and I multiplied by 12. You want to verify your work. So you have the code to do something, and you have also line of code to check. And to delete the column, you just set the column to null. See this data frame column name, and you're going to set it to null. Uppercase, N-U-L-L, all uppercase. See, the column will be removed. And I run the head command again, and I don't see the column, right? But if you did this mistake and you removed the salary column, just an example, if you remove the salary column, what are you going to do? Panic? No. Why? Because you saved all your work in the R script, right? If you accidentally deleted the columns that you did not mean to delete, you would go back up to the code where you're reading your data and read the data again. No worries, and you would rerun all the commands to where you stopped it, right? So next thing is sorted. Oh, well, I forgot to mention why we remove the column. Well, sometimes the column is a unique identifier, right? So, and a unique identifier does not have an impact on analysis, but it could slow the algorithm, right? So when you get to neural network, you would want to remove the unique identifier. Sometimes the columns could contain personal identifying information, such as credit card number, names, right? Those things need to be removed. Sometimes something so the column could be very skewed. Or for example, there could be a country column and everybody is in US. So what's the purpose? We can remove the column will be removed, right? Just to save the required space, right? Or if the column perhaps has most of the values missing. Well, I'm just giving you examples, right? Sorting. Sometimes we want to see, for example, 10 list, 10 best, etc., right? So how do you select top 10? You have to sort the list, right? You have to sort it first. Or sorting could also be useful to identify the duplicates as well. So here, I'm going to create the data frame and I'm going to call it HR sorted. But how do I specify the selection criteria for the rows? I want to order. I want to sort this by satisfaction level, right? I'm selecting the rows sorted by satisfaction level, and I want all columns because I never said what columns I want. So see here, and then I preview, right? And if you want to sort the descending, you need to put a minus sign here. Minus sign goes next to the column name. So that will sort in descending order, right? And I can always preview. And also, here just shows you that you're not limited by sorting by one column. You can sort by multiple columns, okay? So that's multiple columns, all right? Earlier, I mentioned that there are different data types. Some columns are factor. What is factor? Factor, it means that we know the number of values are known in advance. The values are discrete. For example, salary is a factor because the values are low, medium, and high, right? On the other hand, average monthly hours, it's not a factor, right? Because it's a continuous number. Salary, well, in this case, it's just defined like this. It's an assumption. It's how the data is defined. We defined it how low and medium. If this was the actual money, right, actual income, then it's not a factor. Then it's a continuous number, right? But for the factors, some functions are a little bit. There are some functions a little bit. Some functions are only for factors, but we'll see. But hold on, wait a minute. We have a column here that stores if an employee still works for the company or if an employee left. If you look at the summary, right, I did not like by default how it gave the 5-number summary for that column. So see, if I run the summary command, see right now, how can somebody half leave? See, the mean value totally doesn't make sense because you either stay or you leave, right? So it's actually, conceptually, it should be a factor, right? So for some analysis, depending on the method, you want to look at it as a factor. So this is how you convert this to a factor. You're assigning it, right? This is an assignment. You're assigning column left to itself converted to the factor, right? So I run this. Now, if I'm going to run this command again, I'm going to see how many people left, how many people stayed, right? And this command in here is going to check if it's a factor and it's going to return true. So for the factors, you can run the frequency count. So for example, here, I can do the single column, salary, right? I want to display how many people have a high salary, how many people have low, how many people have medium. Well, you saw it displayed differently before, but I can also use a table command because the table command can be used as an input. When you start doing the bar plot takes what as an input? The table, right? So this is how you do the table. This one is just shows the proportions table, the percentage, right? It's just showing us the percentage of people with a high salary, percentage of low, and percentage of medium salary. And here, a frequency table with 2 columns. I specify, and it's going to show me this, see? The frequency table for 2 columns. All right? So just know that. Missing values. Well, as I mentioned earlier, some columns in this data have rows without the value. But then, let's look at the last evaluation, right? So how many months there were since last evaluation? I'm going to run the min command right now on this column. And what's going to happen? Ouch, why? Why did I get an A? Why didn't I get the average for that column? Well, because you have at least one row that is missing value for that column. So how do you, what is the workaround? Well, if I don't want to handle missing values at the moment, but I still want to get the average, right? There is an option to ignore missing values. The min command here takes an a.rem parameter. By default is false, but you need to set it to true. You need to explicitly ignore missing values for this to work. So now I'm going to run it, and it's going to return the expected result. It still calculates the average and ignores the row with missing values, right? So how do I know if the data has missing values? There are multiple ways to check. Well, we look at the summary. But what if my data set has 2,000 columns? Well, we're going to take it slow. First of all, let's check if there are any missing values. How do we do it? Well, see here, like is NA HR, this will loop through all values in HR data frame and check if they are missing. Any, it's going to return true if at least one value is missing. So I'm going to run it. It means that your data somewhere has at least one value missing. All right. Now here, I want to see how many values are missing. So here I'm going to run the sum command, and it's going to take this as an input. It's going to take check for missing values as an input, right? And it's going to count how many values are missing total, right? Total in the data. There we go. I know that my data has two missing values missing somewhere. All right. Well, this is just, well, I know that last evaluation is a column missing values, right? So, because earlier we figured out that I have, earlier, right, we figured out, we saw the output of summary command, and we saw that last evaluation has missing values. But here I want to know, I just want to know how many values that column is missing. It's missing one, but this is how to see the programmatically, see? What I did here, I'm using isOrday command, but instead of specifying the whole data set, I specify, instead of specifying the whole data frame, I specified column name, right? But here, I want to see more. I want to know which row is missing the value. So let's choose a row. See, this is row number 375, okay? If I want to show the actual observation, the actual row where at least one column is missing a value, see, this is one way. Remember here, I specify which rows to pull, and I want to specify not complete cases. The complete cases returns rows where all values are specified. And this is a negation, see? Exclamation point is a negation. So here, I want to pull all rows. I want to pull only the rows where I have at least one value missing, and I want to list all columns, of course. So I'm going to run this command right now, and there are two rows. Well, there it comes. See this last evaluation, and another one is average monthly hours. It's missing one value, all right? Here, I can also check for each column, I can check how many values are missing, right? So see, this is just going to be for each column. Call sums. So see, this one is going to return true or false for each value, right? And I'm just going to look at each column individually, see? So I want to know how many values are missing per column. Those are just the analysis. But again, you know, missing values could be a problem, but how do we handle it? Sometimes, in some cases, you want to omit the rows with missing values. For example, I want to create another data frame called new HR, and I'm going to set it to, see here, this is NA omit. This will remove the rows missing at least one value, right? So this is one way. See, I'm going to do it one way. And another way is just to show the complete cases. Complete case is just going to show if all values are missing. That's another way, but it's going to produce the same results. right? Well, the problem is sometimes I might be using valuable data when I remove rows, right? Maybe I have a column that's missing half of that missing a value for most of my data. Then I could just I can just omit that column. Or sometimes I want to still keep that row, but I want to set it to the column average. How do I do it to the column, to set it to the column average? Well, here, what you do is you're gonna set it here, see like last duration, right? First of all, well, you want to do it a piece at a time. This piece here returns the last evaluation average. Do not forget to say NA.rm equals true, right? Because otherwise you're not gonna get the average. Remember, there is a missing value. So here, this is a column average. So you need to assign something to the column average, right? This is assignment. This is a column average. But what do you assign to the column average? So here, you have to specify. So here you specify in which rows to choose, and you are choosing the rows where last you're looking at the column, right? So this is a column, and you're looking at the rows where it's missing, where last evaluation value is missing, and you're setting it to the average. Alternatively, it's possible to set the value to the predefined value. Like for example, if average monthly hours is unknown, you can just treat it as 200. You can set it to predefined value, right? Now what I'm gonna do, if I'm gonna run the summary again, there we go, missing values are gone. And now I can check again if there are missing values. No, right? I just took care of missing values. Packages. I know it's a lot to cover, but you're gonna need to look through, read through this. You may need to watch this presentation again. But package is a set of functions, right? So I go here, this is a packages. Well, as I mentioned earlier, there are two types of packages. System library, what was pre-installed, and the user's library is what you install. You will be installing a rules package for exercise 2 and 3. Okay? So that will be your first package that you do. But here, this is how you see all available current packages. There are a lot. Nobody's going to ask you to do a lot. But, at your leisure, you might be interested in exploring some of those. Library is going to list the installed. It's going to list the installed packages that you have installed. Right? So this is a library. And it just shows the package location, where it's located. Right? What type of package is it? All right, so let's close this out. This is a location. I can check where in my Windows, well, I'm using Windows, yours is going to be Mac, but still, you might be using Mac. You might be using either Windows or Mac. But this is a Windows example. It shows where the packages are installed. So here, this is pre-installed, and this is what? This is my local library. This is my local folder, right? Lena, well, it's my PC username, my childhood nickname, see? So that's gonna be users, your PC user. This is gonna be update local, R. See, and this is our version. Oh, and for those of you who may have taken R before, you will be installing new R. But when you install new major R version, like for example, if you go from 4.3 to 4.4, right? A new subdirectory will be created. You will need to reinstall the user packages again. If you used version 4.3 before, right? And now you want to make sure that we want to make sure that everybody is using the same version, right? But how to make sure everybody is using the same version, the latest? So if you took R before somewhere, right, and you already have it installed on your PC, you will need to install the latest version. It will take care. You don't need to uninstall the older version, but install the latest, and you're gonna see another folder created. See, you're gonna see another folder that will be created. So I can literally take this path here. Let's take it up to here. See this? I can take this path and I can go to my folder and paste. See, this is a folder. See, this is a folder, see? And this is a library. Notice that on this computer, on this PC, I had versions 4.2, 4.3, 4.4. It's not going to be the case when you update it to 4.4.1. But if you update from 4.3 to 4.4, see, this new folder gets created. See? Here are the packages that I have installed. Those are the packages. And if I go back to older one, those are the packages that I had installed at the time when I used 4.2. See? But now if I'm using 4.4, if I wanted to use coin package again, for instance, I would have to reinstall it, right? Because it's not in my 4.4 folder. See, so I showed you where it's actually stored. And again, see this here? This is in brackets 1, in brackets 2, because this is a vector. See this element here, position 1, element at position 2, right? Now you're ready to install packages. What you're gonna do is you're gonna run install packages, and in here you're just gonna specify. You're just gonna specify the package name in the quotes. That's it, and this will install the package. I'm not gonna install it again because I already have it installed, right? So that's the package. But remember this: the package is installed, but it's not available if it's not loaded in memory. How do I know it's not loaded in memory? Well, one way is, see, there is no check mark next to the name. That's one way. Another way is to run the search command, and if the package is not listed, it means it's not loaded in memory. To load in memory, there are two ways. One way is to run library command, or you can also run the required command. But see, library, what is it doing? You may see, wait a minute, in error. It's an error. You may think it's an error because it's in red. No, this message is informative. What it says here is that your rules package has some functions that depend on functions in the matrix package, right? Well, and also, well, wait a minute. It says, wait a minute. You have some functions in this package with the same name as functions in this base package. So what happens is that you have basically the package that you are that you're loading in memory has some functions with the same name that another package that was loaded before. This message is just informative, okay? But whenever you have two packages, right? Whenever we have two packages that loaded in memory and a function with the same name, very easy. You would just qualify the function name with the package name. So no problem. But here, this is just a message. It's just for your awareness, right? It says loading required package matrix, right? And now it says attaching package rules. And this is just telling you that you have a function, you have a couple functions in that package that have the same name as the functions in package called base. Okay, this message is not an error. So I loaded it, right? But I can also unload it, see? And when I unclick, it runs detach command, see? Now, unloading it does not delete the package, it just removes this from memory. Another way to load it is to run require command, right? See? That's just another way, okay? You can learn more about packages. So when you run this, this is how to open the package documentation page. You run the library command, then you put help rules. That's a package name. So what will it do is it's going to open the page. See, this is the information on package page. All right. You can see the vignettes. A rules package has vignettes. Some packages do not. Some packages do. Well, see what it does? It's opening this. But where is the stored? What is this? Remember, I showed you the folders where the packages that you downloaded are stored, right? Well, see this is my rules package. And what is this? Those are the codes, and those are the what? Some data set that gets pre-installed when you install a rules package, right? There is some help documentation. This is a vignette that we were just looking at. Those are just useful example, and that's a help pages, etc. Right? So it's actually saved here on your PC. It will be on your PC in your case. Well, you can browse through vignettes, and this is how to update all packages. Right? You have to make sure you're working with the latest version. Detach package will unload from memory, and this will permanently delete. And if you need to reinstall again, you can install again. Another topic is the data visualization. All right, so most of you are familiar with the histograms, right? Well, what does a histogram do? It's useful for numeric columns, and you want to show the frequency. Oops, why did it select blue? I don't know. All right, so I want to look at the histogram for the average monthly hours. Histogram is useful to display the frequency, and I run the hist command, and I specify the column name. So this is my histogram, right? Well, but notice that I can modify if I do this, if I run my help command, right? This is a help command for the histogram. I can read what else I can do, right? I can go beyond the minimum, and I can specify the border. I can specify the shading angle, etc. And I can change the title of the chart. I can relabel the X and Y axis, etc. Right? Like for example, I can change the number of bins, right? As that does it, it's gonna show close to 20. I can change the border, and I can change the color. See? You may use multiple input parameters, like what this will do. Let's see what this does. I want to do the shading, and I want to do blue color, and I specify the density. I specify the angle, right? And I want to specify the number of breaks, right? But here I also rename my x-axis. XLab renames the x-axis, see? Bar plot takes the frequency table as an input. So here, as an example, suppose that I want to do the bar plot for the salary column, which has values high, low, and medium, right? The categorical column. So, or the factor column. So what I'll do right now, I create this table and store it into salary table. I can do it this way, right? Can't I? See this? Now, I have the bar plot command that takes the salary as an input. Well, I can do it multiple ways. I can take this here and paste it straight instead of creating another variable, right? But I chose to do it this way for some reason here. Or what I could also do is if I read the help page, I can see that I can sort this. I want to order the bars by height ascending, right? Because see, this is not. I want to show the most dominant first, right? So how do I do this? I just run this command. See, this is gonna be it's least dominant first. See, I want to show this ascending. And I can, if I want to show it horizontal, I can show horizontal too if I want, right? So I got a bunch of options. Not sure what it's doing, but okay. Oh, I'm missing the parentheses somewhere. Okay, well, the idea is you can here you can specify the parameters. You can specify the number of parameters that you can have, right? But I see where it is. I missed something here. I'll have to check. Okay. Now, pie chart. Pie chart takes the table as an input also. But, well, the pie chart are very useful when you want to see the relative frequency. Like, for example, salary, very easy because there are only 3 values, right? What happens when I have 100 values? This plot is going to be cluttered. So it works well only for small number of values. Use bar plot when the number of values is large. Okay? Box plot of numeric columns, right? Box and whiskey plot for numeric. There is also generic plot function where it will try to guess the correct plot I want to see. Like, for example, this is for categorical column, I specify, right? There we go. It will show bars. But I can also do the line plot for a single categorical column. So I'm taking the salary column, right? But here, see this, it's going to show the line because I'm going to plot the frequency. I'm plotting the frequency here, right? This is just for 2 categorical columns. Then you have the cynical numeric column, not a good example here, but in general, you know. All right, and the 2 numeric columns. I'll quickly go through the slides just to make sure I did not miss anything important. And summary, right? We talked about different windows. We talked about the vector. I'll give you the slides. I spelled it out, what I talked about here, okay? I spelled out. Talked about the help system. You're gonna love help system here, right? You're gonna love the commands history, but still, save all your work in a file. You remember working directory, right? What is it? Because otherwise, you know, if you don't set the working directory, R will be looking for the file and it won't be able to find it. You need to specify where you save the file, right? So that's how to preview data, etc., right? We looked at this, but I just put the output here for you because when you watch this recording again, you have it in front of you, right? You have this output. We talked about the subsets, right? We covered everything here. He covered the descriptive statistics, right? Covered. We covered different data types, how to get the frequency count. We covered missing values. This is a very important topic. Missing values is very important topic, including the options for handling them. And you're going to see it more in the later coursework. And packages, right? You're using rules, and later on in the course, there will be packages for decision trees and for the neural network, okay? Those are just some of the commands. I summarize them here for the packages. I put data visualizations, but there are so many. So I decided to give you a little summary, when to use which, right? To exit RStudio, I forgot to run the Q command to exit RStudio, but first, you need to make sure that you save your work. See, you want to save it. See, file, save, right? In this case, save is gray out because I saved the latest change. See, that's a file. I saved the latest change. That's why it's not telling me that you have to save. And also, if you notice that your working directory is going to have 2 files. And what are the 2 files that R creates? R history, this is a file. It will be located in your working directory. And R data. So R data is a workspace image. R is trying to save the workspace image and the history, see? So workspace is a collection of objects. that you created during your R session. And when you start brand new R session, right? See the objects that you saved in our data file, they will be loaded. They will be loaded in a workspace. See, basically, see, you have the history, and you have this here. It's a workspace image. It saves the image of what you currently have in memory. What I have in memory here. See, sometimes I have to be careful. Before I end the session, I may want to delete things that I don't need, because next time when I attempt to load R, it will attempt to load all of that in memory. And trust me, I've seen students kill R, not on the PC, but I've seen it in the cloud, where the student, RStudio for the cloud, the student would create a lot of objects and forget to delete. And the next time when they try to load the RStudio, it was taking a little bit of time because it was trying to load the workspace. Oops, okay. All right, that's a folder. Okay, so there is a cognitive class webpage where you could find some additional R stuff after course is over. If you want to learn more, I just have to put some resources, right? References need to be specified, if you will. So there are a couple groups on LinkedIn I'm a member of. Sometimes you may find some interesting tips, tricks, right? Here are some additional links: the RStudio documentation, R data mining book, etc. There are plenty of resources in the classroom, but I had to list some resources because I did not make things up. You know what I'm saying? I make my examples, but still, if I use something as a reference, you have to specify, right? You have to specify what you use as a reference. So at the moment, what you've got 2 exercises, right? The exercise will help you learn. You need to do it, even though you're not asked to submit the exercise for the grade. You need to do it because it will prepare you for the graded assignment. And also you have a quiz. So for the quiz, you may want to have something like, for the first quiz, you may want to have the output. When you take it, you may want to have the output from both exercises next to you, because there are questions in the quiz on the output. And another thing that I wanted you to be aware of, okay, suppose that you took the quiz, right? You got your 20 questions, and you're trying to write down question 1, answer A, question 2, answer C. No, you're not going to help your classmate. Do you know why? Well, the questions are selected randomly from the pool. So when your classmate is taking a test, taking a quiz, they may not get the same questions as you did. And answer choices, the order of answer choices is randomized. But please don't be scared. And all these questions, some of those questions were discussed here. I'm not going to say, hey, this is a question X from the quiz. No, I'm not going to say this is a specific question, but it was covered here. It's covered here. Some of it has to do with exercises that you're doing, right? There are 2 exercises that you need to do. There could be something on the output just to make sure that you actually ran that code, right? That you read the Word document. And you can use anything you want to use. You will see the timer, but the time is actually unlimited unless you reach the environment timeout, right? And you've got 3 attempts, I think. Yes. All right, so don't worry. But again, when you reattempt, you may get different questions. And the order of answer choices is random. So do not try to write down, okay, the answer to question 1 was A, but because your classmate may get different question 1 and different correct answer choice. And one more thing to watch out this. If the question stem says to choose 2 answers, please select 2 answers. It tells you. If it does not tell you how many answers to select, it's one answer. If it tells you to choose 3 answers, you need to select 3. If you choose only 2, then it means it's incorrect. It will count as incorrect. There is no partial credit, all right? Because the assumption is everybody knows how to count until 3 or until 2, whatever it is, right? So if it's going to say, some questions say to choose 2 answers, some questions say to choose 3. So just remember. Okay, I just wanted to give you a heads up. Okay, so now your turn. Questions? Questions? Anything that you want to ask? Please, it's your turn. Questions? I know that you will have questions as you work with this, but anything, any concerns, any issues right now?
Hi, how you doing, ma'am? Can you hear me?
Yes.
Are there going to be any more webinars, or this is the only one throughout the whole semester?
The recordings.
Okay, got it.
Yes,
Thank you.
the recordings. Sure. The recordings are posted. There is one on association rules. There is something on decision trees. Yes. So no worries. But for the first one, I decided to do it live because it's the first one, right? Good.
Okay, thank you, ma'am.
Perfect. Anything else? Well, so you're gonna be getting the recording. You're gonna be getting R code. You're gonna be getting the slides and also the files that I use, because if you want to follow along, if you want to practice with the code I'm giving you. Okay? Well, if there are no more questions, I'm gonna call it a night. And I want to thank everybody for attending. All right, and good luck. Have a nice, enjoy the semester, enjoy the course. All right? Okay.